Welcome, everybody. I'm Frederick Stotts, so you can call me Fritz with the Standard Company.
I'm Karen Peterson, and we're both here from Standard Insurance. And what we're going to try to share with you our journey into DevOps. And we're both actually on what we call a build and release engineering team. So we're actually doing the engineering to try to engineer the actual technology of the pipeline. Okay, so I just want to tell you a little bit about Standard Insurance before we start. It was founded in 1906. I believe it was the first insurance company on the West Coast, and that it was motivated by apparently, like, in the logging industry, and people would have either injuries or death, and they would have to go right to the East Coast, and it would take months and months and months before they would get reimbursed from their insurance companies. It's a wholly owned subsidiary of Meiji Yasuda, which is a Japanese company at this point. There's almost 3,000 employees. Most of them are actually in Portland. Our assets are $26 billion. We're basically, we have several businesses. It's fairly complicated. We are an insurance company. We do life and disability and individual annuities and workplace insurance. And the only medical insurance we have is dental. And then we have a whole nother division that does employee benefit plans, which includes 401k plans and various things. And so we actually have a whole lot of technology for a company our size, because we are not just doing one thing. So it's a challenge. And IT is a large expense, and we basically need to get better at providing true value to the business. So go ahead to the next.
I'll just make a comment. It's actually a very interesting place to be right now, because the company is very much in transformation. So, it is 112 years old, but it's also in a transformation in terms of moving to a lean management style across all lines of business, and an agile transformation in terms of development, and moving into really trying to embrace sort of DevOps premises. But it is a company in transition right now, so we haven't finished the journey. So we're going to show you a snapshot of the pieces that we're doing to make steps in that direction.
Okay, so this is our mandate, really the mandate of IT, and it comes very close to our department. We need to improve our cycle time and quality of the stuff that we deliver to the business. When they come to us and they need functionality added to our apps or new apps, we need to get that to them quicker. And so we believe that a big part of that is automation. Okay, so what we're going to talk about here is, why automation? Why do we think that automation is going to meet that goal? And tell you a little bit about our team and what it's made up of and how it's been successful. A little bit about our philosophy of how we chose to implement this automation. And then we'll show you how our single pipeline actually works, and what our progress is up to date and where we're going. Okay, so the reason for automation is that, so what we had before we started was a very manual process for both builds and deployments. Developers would often do builds on their own PCs. Usually there was a source code repository, but the build was, they do the build, they put the build on a network drive, and then they would ask somebody to deploy it. So as you can imagine, it can be very error prone. You're not entirely sure where the build came from. So we really need a way to have stronger traceability as to what's deployed. When you ask the question, well, when was the last time somebody changed that in production? We need to be able to answer that. When you ask the question, do we have the same thing in our test environment as we do in production? Do we actually test what we put in there? You need to be able to answer that. And again, quality is a big part of that. We can't just be faster. We can't just say, well, we know where it came from and we got it there really fast. It actually has to work. So we need to consider that in our automation as well. So the other thing that, and we really haven't gotten quite to this yet, but we have it in the back of our minds. What we've been doing is tackling individual technologies. So automating the deployment of JBoss apps, and automating the deployment of WAS apps, and automating the deployment of message broker flows. But in reality, or automating database schema updates. But in reality, when we do an actual release, we often release several technologies at the same time that have to be compatible with each other. So, you know, the front-end app and the database have to work together. There's changes that have to happen at the same time. If you just updated one, you'd break it. So that is something that we actually have to tackle, and we've got some ideas on that as well.
Yeah, so from a philosophy standpoint, from a methodology standpoint, what we're trying to do is, we're an automation team, so we're bringing automation end to end for deployment in the company, but that doesn't solve the whole business problem everywhere. But what we can do is we can take that technology slice and automate it, and then make it the most attractive path for the development teams to actually be successful. And then we move people, parts of applications, into that automated pipeline, and every time we add a technology slice, it's easier because the teams have seen it in other parts of the technology. So here's some information about our team. We created a brand new team. I was the first member on the team. I'd actually been at Standard for a couple years, so I had a little bit of experience with what the current situation was. So I knew where some of the bottlenecks were and what kind of technologies we had. Then we started hiring people. We hired Fritz, who actually had done automation before. He's done this before. So it's exciting for him to get to do it again with everything he'd learned in the past. And we hired some people that had more infrastructure kind of experience. So we got a rounding of experience. And I listed here some of the technologies that we've had to become experts at. Some, there was some expertise that came in. We had to learn stuff. Nobody knew the Zebia tools before we started. And we try to make sure that the team, that we're not just one person knows one thing. We try to do, and I think Sunil mentioned that too, we try to do some cross-training between people so we don't have a single point of failure. So one of the things I'd point out is we're a relatively small team for the scope of what we're trying to do on end-to-end automation. We only have 5 SIC employees, and we have a bunch of contractors, but they're very focused on particular technology pieces. And so we need to do things to make the process efficient. We don't have we have dozens of development teams that we're supporting, yet we only are able to spend a little bit of time with each of those development teams. So you'll notice in our implementation process and philosophy that we did a lot of things to optimize how we can be effective for a larger organization with a small team. So, so what we've built into the pipeline, for quality, basically, is the pipeline itself actually has built in, it does a build and it runs unit tests automatically. If the unit tests fail, it fails the build. We also have built in some static analysis tools, and we built in something called Sonar Cube, which actually collects reports from static analysis tools so we can do trending. Sunil talked about this a little bit. It's going to be a long time before we have complete test automation for every application. So we need the ability to run automated tests as well as track manual testing. So you'll see when we show you our Excel release flow that there's steps in there for doing manual testing as well. So the question was, what is the frequency that this flow gets run? It varies wildly. We've got teams that are still essentially acting like a waterfall. and they're running the flow infrequently. But we've got teams that are doing multiple builds a day, and the check-in and build to the first level integration environment is CI/CD. You check in your code and it shows up in your integration environment within a few minutes. And so some of the teams are doing that multiple times a day, and some of the teams are not. It's not an even thing across the organization yet. So we have some teams that are relatively small. They're working straight on the development branch. Every time they check into the development branch, they're getting a build, and it's a handful of developers on the product. We have some larger teams where they literally have half dozen feature branches that are being worked on in parallel. They're doing pull requests to the development branch, and they're much larger sort of coordination. And our flow is trying to accommodate both kinds of customers. The kind of customer that's, I'm doing a maintenance fix and I got one line of code change that I need to do, and I've got a team of 5 people working on a feature, and it's going to take them 3 iterations to get that feature done. And we're trying to accommodate in one flow the ability to work both ways. So right now, the unit tests are really developer-driven tests. They're checking in the code. The post-deployment automation tests, the Selenium grid-style tests against web applications, is done by a separate test team. We are, as a company, trying to merge them closer to get more of a unified test plan, but that is a journey that we're still on. We haven't really achieved that yet.
Okay, so on the subject of better traceability, we used a few different mechanisms. The first one is we have a consistent versioning scheme, and I'm going to talk a little bit more about that on the next slide. But the point is that for every artifact that we generate and deploy, there is a versioning scheme that they all work the same way. We use something in Jenkins called fingerprinting, where we can actually, if the artifact is created in Jenkins, it fingerprints it, and if that artifact ends up on a server somewhere and there's any question as to where it came from, you can download it back into Jenkins, and Jenkins knows where it came from. And then the third thing is actually Excel Deploy itself, one of the Zebia tools. It keeps a complete record of all deployments. When did it happen? What version of the artifact did you deploy? So we are able to go into that tool and answer all those questions about, what was the latest version, when did it happen, do they match across the environments, all that kind of stuff. So that's a really strong traceability tool itself. Okay, so this consistent versioning scheme, you want to talk to this?
Yeah. Okay. So this is a point of contention with development teams, because generally teams that have been operating independently have their own idea of what versioning should be. But if you're trying to do a pipeline across many products, many libraries, we found that getting a consistent versioning, both in terms of the artifact versioning, but also in terms of naming conventions of repositories, naming conventions of builds, naming conventions of artifacts, that trying to hook that up together in an automated flow solves an immense number of problems. We do have to go in and have essentially political discussions with development teams to convince them that there is value to the company to adopt a versioning scheme that isn't the one that's perfect for their one little corner of the world. We've decided to standardize on a Maven 3-part version, major, minor, micro, and that all 3 parts are always there, and we do snapshot builds in development. And the reason we do the snapshot builds in development is so we can have multiple concurrent development branches that are working separately. The tooling externalizes the version changes. So what happens in every build is is that during the build we check out the source code, we look at the version in the source code, we look at the version that's deployed, and we calculate what the next version should be. So if the development team wants to bump up the version, they have the power to do that by changing the version in their source code. But they can never make a colliding version with something that's already in production. They can't make a hot fix that overwrites an existing version number. And then once we've calculated what that new version can and should be, we write that back to the source code. And then we do the build and see whether the build is successful. And on a successful build in the release, we tag it so that we can, and we use that tag throughout the rest of the flow. So by externalizing the version changing, all of a sudden, you don't have the issue with developers forgetting to set the version or version collisions or different naming conventions or somebody doing it by hand. And it's solved a great deal of rework and confusion that's happened in our older manual processes.
So yeah, just to be clear, what we do is there's a 3-part version number. We maintain that last part. So we make sure that we get a unique version number by incrementing that last part. And the development team can decide with the first 2 numbers how they want to use those. So they would increment the first number every time it went to production, or it was a major release, and maybe the second number if it was a fix. And we don't care how they do it. But we just know that we can uniquely come up with the next number by incrementing the last number. And then when we create a release candidate and we put this artifact in Nexus, we know that we actually go to Nexus and see what the last number was, and we increment it by 1. So we always get a unique number out there.
So we have a rule, it's a business rule, that every repository is 1 version. So when we build, you can have multiple artifacts in that repository, but they will be versioned together. If you want separate versioning, you have separate repositories for those artifacts. So we have some cases where you have a Java application with 20 dependent jars that are being built in the same repository. That's fine, but they're all always synced. If you have an external dependency, a library that's used by multiple applications, it must be located in another repository if you want to version it separately.
So that's how we basically to figure out how to break things up by GitHub repositories. We ask the question, do these things build together every time? Or do they get released together every time? Or is it, they've got separate release cycles. So if they have separate release cycles, we put them in different GitHub repositories.
Yeah. I mean, they're different philosophies, and we kind of consciously chose a space in the middle. You go to one extreme, you look at a company like Google, they have the mono repo. They got, for all their external web presence, they've got a single repository, and everything's live on master, and it gets built, chunks of it get built automatically. And they get consistency between different products because it's all the same source code tree. You've got other projects, other companies, say LinkedIn, where they have binary dependencies, or Netflix, where they've got binary dependencies. They've got thousands of developers, each of them building libraries that everybody else depends on. And they have to build all kinds of massive infrastructure to make sure that when a library gets updated, that everybody who uses that library gets notified, and that it builds and retirement processes for those binary dependencies. We're kind of in the middle. We're not such a small company that we have no binary dependencies between products, but we don't have thousands of libraries. We've got dozens of libraries. And so we're trying to find that middle ground where we've got source consistency between things that can be built together and support that. We've got binary dependencies that are being managed manually. There's no fancy automation around it. But we're trying to hit the sweet middle spot that works for our size of company and the size of our development teams.
Okay, so this is a picture of our pipeline. And so the mechanism that we're using is called in Jenkins, it's called a GitHub organizational folder, or multi-branch. And what it is you go into Jenkins and you create this thing and you point it to an organization in GitHub. And what it does is it scans that organization in GitHub and it looks for all the repos in that organization. If it sees a Jenkins file in there, it stops and says, there's a Jenkins file. And it looks at all the branches and all the repos. And then it checks to see if there's been a commit since the last time it processed it. So if it finds a Jenkins file and it finds that there's been a commit, then it will run the Jenkins file. So the Jenkins file that is in each repository, for the most part, is very small, and it calls our pipeline code. They have ability to override certain parameters. So some of the Jenkins files have some extra parameters in it. And in some of our technologies, we actually have to override the build behavior. We started the pipeline with Maven builds. So the Maven builds the Jenkins files have almost nothing in them other than run the pipeline, and then the pipeline kicks in and it says, and I see a Maven POM file, I'm supposed to run that, and that's what it does for its build. So you can see there the steps in our pipeline. It's a little bit different on the develop branch. So we have two static branches. We always have a develop branch, actually three. We always have a develop branch, we always have a release candidate branch, and we always have a master branch. So the develop branch is our CI/CD branch. So when somebody commits code to the develop branch, it goes through this process. It actually does a build, it runs unit tests, it runs static code analysis, it creates this artifact, and it puts it in Jenkins and says, XL deploy this to the int environment. XL deploy is set up, the package has a label on it, and that label tells XL deploy everything it needs to know as to where to deploy it. Between telling it the environment and giving it a label, it has a way of searching and figuring out where it's supposed to go and how it's supposed to behave. Then what happens is and they may do many builds in the develop environment. At the point where they're ready for a release candidate, something that they want to get up into the higher test environments or maybe ultimately to production, they do a pull request from the develop branch to the release candidate branch. And that's the point where somebody has to do a review. So we protect that release candidate branch. We can't do pushes to it. It has to be a pull request.
The GitHub tool has features in it where you can protect branches. And one of the protections you can do is to accept a pull request. It must be reviewed in the GitHub tool. So we've disabled being able to push code into it. You must make a pull request. And in the process of approving the pull request, there's a code review.
So once the pull request is accepted, it goes through the same process as the develop branch. It builds it, runs unit tests, runs static code analysis. This time it actually versions the artifact with the three-part name. It doesn't say snapshot on the end. It's a new version, the next version, and it puts it in Nexus. So it will be there forever because it's a release candidate. And then it deploys again to our integration environment just to make sure that the release candidate still deploys. And it runs whatever automated tests we have after that. And then at that point, if it makes it that far, it actually calls XL release. So we have a template in XL release. And when we do the demo, you'll see it because it's hard to imagine it if you've never seen it. But we instantiate an instance of that template, and we pass all kinds of variables to it. We tell it what the product is, what the artifact is, what the version of the artifact is, and some other behavior. And we even have the ability in the Jenkins file to override some of the behavior in XL release, and we'll show you a little bit of that in the demo. So at that point, it creates this release. So now the release manager actually is in charge of actually deploying it out to the other environments. So we still have automated deployment. It just takes one button for the release manager to say go. But it doesn't happen automatically. So the release manager can decide, working with the projects, when do you want this going to the next environment? When is the business ready for acceptance testing? And then ultimately, when does it go to prod? And then there's a procedure when it goes to prod that there has to be a change ticket. And once they've gotten their approval, they can push the button and it goes to prod.
So this is where the one pipeline to rule them all comes in. There is one code description of this pipeline for every instance. There's not 1,000. I've seen places that had 1,000 or 10,000 freestyle jobs in Jenkins. We have one pipeline that generates all these from the GitHub repositories.
And how many applications do you support?
Well, we'll get to that until the later slide. But multiple technologies, everything is diverse from .NET applications, Java JBoss applications, microservices, database updates, reporting. They're all using the same pipeline.
Yeah, we have over 500 applications that are being in this.
And we're not doing any work in Jenkins to maintain it. All of this is automatically updated in that tool. We've completely cut out that sort of maintain 1,000 pipelines, maintain 1,000 branches kind of work. That's something we don't do.
Okay, so this is a picture of the same thing, but I just drew it a little differently. And it kind of shows you more from a people perspective. The developers interact only with GitHub. Their interaction with Jenkins is only to look at output. So they can go into Jenkins, they can click from GitHub and get the console output from the Jenkins job that runs. But they don't generally start jobs from Jenkins. They just make their change in GitHub and it automatically takes it and runs it. If you look at the blue line there, that is if they're on the develop branch. So if they actually commit something to the develop branch, it follows the blue line, it goes to, it creates the artifact, it goes to XL deploy, and it automatically goes to our integration environment. When you look at the purple line, that's from the release candidate build. And on the purple line, you can see it stops at the release manager. So we have probably about 20 release managers to support the whole organization. And what we do is when it creates that XL release instantiation, it reads a file, a CSV file, and we have mappings from applications to release managers. So that way the correct release manager will get notified, hey, there's a new request for release for this particular application. Another thing, I just want to mention one more thing before we do a demo, is something that it's a strong thing that XL Deploy supports, and it's about environment-specific values. So you can see from our pipeline that we build once and we deploy many, right? We don't rebuild it for each environment. But in reality, there often are environment-specific things. So for example, like the database it needs to connect to, that's different in each environment. So we need a solution for that. We can't do the build once, deploy many without a solution. So Xebia provides the concept of environment-specific dictionaries, and they can be associated with environments and applications. And what they do is they will look at your artifact, they'll take your zip file and open it up, and they'll look for placeholders. And they'll do a search and replace before they do the deployment. So we went to our developers and we said, look at these cool dictionaries. And they said, huh. So every time we want to change one of those values, we have to come to you? And I said, I don't like that. So we ended up actually externalizing those into, what we did was we created, in the GitHub repository, we created an orphan branch, which is basically kind of like another repository because they don't track each other. And we put properties files in there. So we have one for each environment. And then we put a special Jenkins file. And we have another, so we actually do have two pipelines to rule the world. But what that does is it reads those properties files, and it looks in XL Deploy, and if a dictionary doesn't exist for that application in that environment, it will create it, and it loads it up. Or if you change the values, it'll go in and change the values in XL Deploy. So the maintenance of those actual values and those key value pairs is actually done by the developers. Occasionally we have a value that's a password that's not encrypted, so we won't put those in GitHub. So the dictionary itself actually has a section for encrypted, for passwords, and XL Deploy encrypts it. So those we actually have to go into XL Deploy and put in. Then we figured out that we have actual situations where there's environment-specific values, but they're not application-specific, they're technology-specific. So we actually came up with a way to actually have default dictionaries for technologies.
So we have a central repository where we can put in, for every technology, a default int set of properties, a default ACCs, default prod set of properties. And that really simplified the configuration of things.
Okay, so this just gives a quick look at the technologies that we're using. The build technologies are either Maven, Gradle, sometimes Bash scripts. And then these are the technologies that we've actually automated so far.
So it's a large list, and it's not a homogeneous list. There's big differences between these.
And then here's the data on how much we've automated. So you can see I've shown like for each, and I did this a few weeks ago, so it's probably more now, but for each technology, how many we have.
And this is just the technologies in production. It's the list of technologies that we had automated. Some of them are still in the development pipeline. Our group, the first production application was deployed March of last year. So all of this is in a year's time frame. We've developed and created these processes and ported these applications.
Thank you.